So if we look at other derivatives of morphine, such as codeine and diacetylmorphine, these also, you can see, have this morphine rule within them, this structure that you've identified using your VESPR rules and thinking about hybridization. Codeine, as you may know, is less of a potent painkiller compared to morphine, but it's also less addictive. So for that reason, it's prescribed with slightly less oversight. So if you got your wisdom teeth removed or something like that, some of you might have had taken codeine before, and now you can think about, by looking at the structure, a little bit more about how that worked in terms of blocking your pain. One that I just want to mention because it's so interesting is this derivative, which is diacetylmorphine. The only difference between morphine and diacetylmorphine is the changing of an alcohol group, or two actually, to acetyl groups here. This was synthesized by the company Bayer, and you probably know Bayer from Bayer's aspirin. Bayer had a huge success with aspirin where they took salicylic acid and replaced an OH group with an acetyl group here and made acetyl salicylic acid. Does anyone know the common name for that? Yep, so that's aspirin. And we often think of Bayer's aspirin. We associate it really closely. They worked really hard in marketing to make that really close association and with copywriting so that when we think about aspirin, we think about Bayer's. Bayer's also made this change here, and they did find that diacetylmorphine is much, much more potent than morphine is. They could use just a tiny, tiny amount of this compound and get the same pain-killing properties that they saw with morphine. The problem is that this masked some of the side effects that they didn't realize initially, which was the extreme ability for you to become addicted to diacetylmorphine. And this was first thought of as a hero drug because it was such a strong painkiller, and this was called Bayer's heroin. We don't usually associate the name Bayer's with heroin like we did with aspirin. That's because Bayer's did not work so hard to keep that association there. But it's just an interesting story from the history of drugs. One more example I want to show you is Demerol, which is used clinically quite often. Demerol, if we look at the structure here, actually looks nothing like morphine at all. So to an untrained eye, you might not see the relationship there, but because you all know some of these basic principles of chemistry, you should be able to pick out that morphine rule right in the middle of Demerol. And in fact, Demerol is a painkiller. It's an alternative to using morphine. Again, not quite as strong as morphine in terms of pain-killing abilities, but also not as addictive either, and there are some other side effects, such as nausea, that are limited with Demerol compared to morphine. Demerol has its own set of problems, so it's not the perfect solution to a different alternative to morphine, but you do see it used in certain cases.